So we're going to open our IPYNB file or Python file. Let's open this right now, and there we go. So I remind that this notebook is in read-only mode, and since we, as usual, want to re-implement this from scratch, we're going to go to File here to create a copy by saving a copy in Drive. And as you see, it is creating a copy in which we will be able to re-implement the whole model from scratch. And there we go. All right, so now, as usual, we're going to delete all the code cells so that we can re-implement this from scratch. Make sure to only delete the code cells and not the text cells so that we can see the structure. And lastly, this one. Perfect. All right, so this is the whole structure of this implementation. Let's have a look. So we're going to start by importing the libraries, then importing the dataset. Then, as I told you, we're going to skip the step where we split the dataset into the training set and the test set, simply because we want to leverage the maximum data in order to make our future prediction of the salary for the position level between 6 and 7. So we skip this step, and then we move on directly to first actually the training of the linear regression model on the whole dataset. And that's for the simple reason that we want to compare the two models, linear regression and polynomial regression, because I want to show you that indeed a polynomial regression model will be much more adapted to this dataset. So in the end, we will actually, as you can see, predict the salary of the position level between 6 and 5 with linear regression and polynomial regression. And you will see that we will get a much better result with polynomial regression. Okay? So after training the linear regression model on the whole dataset, we will train the polynomial regression model on the whole dataset as well. Then we will visualize the linear regression results on the whole dataset again, and then the polynomial regression result. And finally, we will make our last two predictions, predicting a new result with linear regression and predicting a new result with polynomial regression. And at the same time, you will learn how to make a single prediction, because what we've done so far, when making predictions was to input the whole test set features. But you actually still don't know exactly how to predict the result of a single observation. And that's exactly in this practical activity that you will learn it. Okay, so that will be a good new skill to know, and I will of course ask you to try to do it on your own before we do it together. And so there you go, that's the whole structure, and now we're ready to start, and we're gonna tackle this semi-data preprocessing phase in a flashlight, starting by importing the libraries, and thanks to our data preprocessing template. So I'm copying this here, pasting that right here in a new code cell. Then we're going to import the dataset using still our data preprocessing template, because indeed we will have only one thing to change, which is of course the name of our dataset. No, actually, my mistake, we will have two things to change, and I will explain why right away. So first, let's change that obvious thing, which is the name of the dataset. So let's see the name of the dataset again, position salaries. All right, so let's do this. I'm going to replace data here by position salaries. Great. And now the second thing I wanted to change is of course the matrix of features X, because remember that this automatically takes all the columns except the last one, but actually here, these two columns are redundant. It's like we already did the label encoding, to encode each of these positions into numerical integers going from 1 to 10. But I wanted to leave that column because it's pretty nice to see the names of the different positions, from business analyst to CEO. So we actually don't want to include this column, and therefore we will start to get the column from the second index, which is index 1, right? Because indexes in Python start from 0. So there you go. We're only going to take that column, and to do so, well, we're going to replace that empty lower bound, which means the first index, by index 1, so that it will indeed take all the columns from the second one, of index 1, up to the last one except the last one. And therefore, it will take all the columns from this one except this one, and therefore just this one. See? Just a simple trick. All right, so now we're all good. This will still take the last column, the dependent variable vector containing all the salaries. So we're all good. And we can move on now to the next step, which will be to train the linear regression model on the whole dataset. Great, so would you like to execute this now? Yes, maybe let's do it now so that it's done. So let's click this folder here to be able to upload the file. Right now it is connecting to a runtime to enable file browsing, and in a second, yeah, there we go, we should be able to upload the dataset. All right, so we're going to go to our machine learning A to Z folder. I always put it on my desktop, then part 2 regression, then section 6 polynomial regression, then Python, and there you go. Let's get and upload our position salaries dataset. That's all good. Now we have it, so now we can run these first 2 cells. First importing the libraries. Okay, done, and now importing the dataset. And done as well. And now we can move on to the next step, training the linear regression model on the whole dataset. So try to do it on your own because you now know how to implement the linear regression model. So I trust you will smash this. There is no trap, and this will be a good way to practice again. So as soon as you're ready, well, let's move on together to the next tutorial to build that first linear regression model together and then the polynomial regression model. And until then, enjoy machine learning.